So this is week 11 area, and we'll click on experiment number 11, balancing chemical equations. Okay, you see the objectives, and then this is the procedure part of the experiment. And you'll have to answer assessment questions. So after you read the procedure and follow the steps, you'll answer the questions here. Click on the link, you'll begin the lab assessment. And again, the lab assessment has unlimited time. It is resumable. You can resume it. If you close it, just make sure not to submit it. And it's 2 attempts. Okay, 2 attempts. Remember, guys, always the second attempt is taken for grade. Okay, and you'll see actually the questions. Very simple here. Other questions and some exercises after that. So you have to answer those 20 questions, okay? So now let me show you the procedure part. So if you click on the procedure here, okay, you should see now the procedure. When you download the procedure, this is what you'll get. And now it's very important, guys, to watch those 2 videos, okay? Those 2 videos, 2 links will prepare you for balancing chemical equations. So start by watching those 2 videos, okay? Then after you watch those 2 videos, you can download the simulation. So click on the simulation, you just hold the control button and left click it, and this will open the simulation. I have here screenshots for the steps you need to do step by step with the screenshots, as you see. Okay, the score you are getting and so on. So just to show you here, let me open the simulation. Okay, so when you click on the simulation link, this is what you'll get. You'll click play, and this will open the simulation. You should not have any issue with the simulation. You'll be doing the introduction first, and then you'll be doing the game part. Okay? And the game part, there are several levels, level 1, level 2, and level 3. You are required to do level 1 and 2. Level 3 is optional, okay, within the game here. So you have 3 levels. Make sure to do the first 2 levels. I would recommend the 3rd level as well. The 3rd level is a little bit more challenging, but it would be nice to do level 1, 2, 3 as well. Now in level 1 and 2, you should get at least 8 out of 10, I think. 8 out of 10. If you get less than 8 out of 10, you have to go back and redo it. Okay. So if you got 6 out of 10, you have to go back and redo it until you get 8 out of 10. So first, look at the introduction here. The good thing here about this simulation, it shows you the molecules. Okay. So for example, you are asked to balance this equation. Now let me talk about a few things here before I show you the simulation itself. Let me show you a chemical equation. For example, we all know about water. So if we type here a chemical equation, let's say water is what hydrogen will bond H2, will react with oxygen O2 to form water H2O. Okay. This is water. Now, in any chemical equation, you have left-hand side. The left-hand side here represent what we call it reactants. Those are the reactants. So those are reactants. And the right-hand side represent the products. In that case, here we have only one product, so product or products. Okay. And this arrow here stands for yields. So this is a chemical equation that represents chemical reaction. It tells you that hydrogen, H2, will react with oxygen, O2, and this will yield H2O, which is water, dihydrogen oxide, water. Okay. Now, what do you mean by balancing chemical equation? When we talk about balancing chemical equation, what do we mean by that? Let me erase this one here. Balancing chemical equation means that we have to make sure that the number of elements on the left-hand side equal to the number of elements on the right-hand side. Okay. So for example, here on the left-hand side, we have two elements. We have hydrogen and oxygen. And on the right-hand side, we have the same two elements. We have also hydrogen and we have oxygen, right? Now the question is, how many hydrogen do we have on each side and how many oxygen do we have on each side? If they are equal, then the equation is balanced. Now you can see here we have only two hydrogen. Okay, so we have only two hydrogen. And we have two oxygen. While on the right-hand side, we have two hydrogen. H2 here stands for two hydrogen. If we want to, let me just give it to you here in the form of visualization here. H2 means two hydrogens bonded to each other. This is the meaning of H2. So you have two hydrogen bonded to each other. O2 means two oxygens bonded to each other. So you have two hydrogens and you have two oxygens. On the left-hand side, you have H2O. H2O, what? H2O means you have two hydrogens bonded to one oxygen. H2O, two hydrogen bonded to one oxygen. So the number of hydrogens is 2 and the number of oxygen is 1 only, because here the subscript is 1. Whenever it's blank, blank means 1. Okay, we can write here 1, but you should know whenever it's blank, blank stands for 1. Okay, so H2O, this is H2O. Okay. So the problem here, the equation is not balanced because the oxygen is not balanced. We have one oxygen, while here we have two. So to balance the equation, we have to make sure that we have two oxygens here instead of one. So we need to change the oxygen from 1 to 2 somehow. We need to change the oxygen from 1 to 2. In that case, we'll balance the equation. Now, how can we change it to 2? Now, someone might suggest that the way to change it to 2 is to change the subscript here to 2. Okay. Now, is this correct? No, this is not correct. We cannot change the subscript. Why? Because H2O is not H2O2. H2O is water. H2O2 is what? Anybody knows? H2O2 is hydrogen peroxide. So those are two different chemicals. They are different. So changing the subscripts will change the identity of the molecule, of the compound. So we cannot do that. We cannot change subscripts. What can we do in a chemical equation? What can we change in order to balance it? We can change something called coefficients. Coefficients are the numbers, or the number here that precede the formula, the number that precede the formula. So I can change oxygen to 2, not by changing the subscript, by changing the coefficient. Okay, so I can put 2 here. What does that mean? If I put 2 here, then this means that I have 2 water, not 1. Okay, so instead of 1 water molecules, I have 2 water molecules. That's 1 and that's 2. So I added an extra water molecule to the right-hand side. Now this enabled me to change the number of oxygen to 2 instead of 1. So now I can, here if I calculate the number of oxygens, the number of oxygen will be the subscript of oxygen times the coefficient of oxygen. So the subscript here is 1 times the coefficient, which is 2. This will give you 2. So now oxygen is balanced. But I have a problem. in the process of balancing oxygen, I messed up the hydrogen. Now you can see I don't have 2 hydrogens, I have 2 times 2. You can see here 1, 2, 3, 4 hydrogens, right? Let me use the spotlight here. You can see the number of hydrogen. You have 1, 2, 3, 4 hydrogens and 2 oxygens on the right hand side. While on the left hand side you have 2 hydrogens and 2 oxygens. So I have to go back here and change and recount the number of hydrogens. So now I have 2 times 2. 2 times 2, which will give you 4. So hydrogen is not balanced. I have 4 on the right hand side. I have 2 on the left hand side. So what should I do now? I need to change hydrogen to 4. Oxygen is good. Oxygen is 2, 2. So oxygen is good. Now, how can I change the hydrogen to 4? So I can't go and just put H4 there. This will be wrong. As I mentioned, we cannot change the subscript. We can change the coefficient. So what should I put here? In order to get 4, I have to put 2 here. So now 2 times 2 will give you 4. Okay, this will tell me what, when you put 2 there, this will tell me that you have 2 hydrogen molecules. So you have H2 and another H2 here. So you have 2 hydrogen molecules reacting with 1 oxygen molecule. You can see 1, 2, 3, 4 hydrogens. That's 2 H2, which will give you a total of 4. 1 O2, which will give you 2 oxygens. And now you can see the equation is balanced. 4 hydrogens and 4 hydrogens. So yeah, this is basically one way to do it. And let me delete it here. So here, for example, if you are doing, if you are balancing this equation here, you have H2, N2, and this is ammonia and H3. How can we balance it? You can see here, nitrogen is not balanced. You have 2 on the left-hand side, and you have 1 on the right-hand side. And hydrogen is not balanced. You have 3 on the left-hand, you have 3 on the right-hand side, 3 hydrogens, and 2 hydrogens here. If we assume we start everything, let's say we start everything with 1. Okay, you can see you have 2 nitrogens, N2. You have 1 H2, which is 2 hydrogens. And here you have 1 ammonia. The blue ball here is nitrogen. The white balls are hydrogen. And they are not balanced. So how can we balance it? You can start by balancing the nitrogen, for example. We have here 2 nitrogens. Here we have only 1 nitrogen. So if we added 2 to the coefficient, so now you have how many nitrogens? You have 2 blue balls. The blue ball is the nitrogen. So now nitrogen is balanced. But hydrogen is not balanced. You have 6 hydrogen. 3 times 2 is 6. And you can observe here that you have 6 white balls compared to 2 white balls here. So how can we balance the hydrogen? What should we do here? Since we have 6 nitrogens, 6 hydrogens on the left-hand side. Yes, on the right-hand side, you have 2 times 3, which is 6 hydrogens. On the left-hand side, you have 2 times 1, which is 2 hydrogens. Okay. The nitrogen is good. We have 2 nitrogens on both sides, but the hydrogen is not good. So we have 6 here, we have 2 here. So we have to make this 2 equal to 6. We need to change the 2 here to 6. And to do that, we have to multiply it by 3, right? So we have to change the coefficient here to 3. Okay, so we can add 1, 2, 3. And now you can see you got the smiley face. Means it's balanced. Okay, 2, 4, 6. You can count them, 2, 4, 6 hydrogens. On the right hand, let's see here. Let me use the spotlight here so that you can see what I'm doing. So you can see here we have 2, 4, 6 hydrogens on the left-hand side, and you have 1, 2, 3, 4, 5, 6 hydrogens on the right-hand side. So hydrogen is balanced, and also nitrogen, because you have 2 blue balls, two nitrogens on the right-hand side, and you have two blue balls, two nitrogen on the right-hand side, on the left-hand side, okay? So that's one way to do it, by the way. Let me show you a different way also. Sometimes it might be handy with some complicated equations, okay? So let me go back to the water. Let me use the same water example here. We can solve it using a different method, and it's up to you which method you use. I would recommend the first method for simple problems, but when it gets a little bit complicated, maybe the second method you'll see it's handy. The second method is will focus only on the element that is not balanced, but in the process, we might use fractions. Okay, so if you don't like fractions, this might not be the method for you, okay? So again, here starting with two hydrogen and two oxygens, you see here. So if we count, let me use the blue ball here, okay. So you can see on the left-hand side, we have 1 times 2, which is 2 hydrogens. And again here, in terms of oxygen, you have also 1 times 2, which is 2 oxygens. On the right-hand side, you have, in terms of hydrogen, you have 1 times 2, which is 2 hydrogens. And oxygen, you have 1 times 1. Of course, blank means 1, guys. Whenever it's blank, this means 1. So now we are trying not to mess with the hydrogen, since it's already balanced. It's already balanced. So we're not going to change the coefficient here, like in the previous example. We changed the coefficient here to 2, and then we messed up the hydrogen, so we have to go back and put 2 here. Now here we'll focus on the oxygen. So we want to bring oxygen from 2 to 1. Okay, so that it will become balanced. Now to bring 2 to 1, you have to multiply the 2 by what? What should you multiply the 2 by to get it from 2 to 1? We know you have to multiply it by 1/2, right? So we'll change the coefficient here to 1/2, but we cannot keep it there. We cannot have fraction in a chemical equation. But this will temporarily balance the equation, because now we have 1 oxygen. 2 times 1/2 will give you 1 oxygen on the left-hand side. And we have 1 oxygen on the right-hand side. But we cannot leave it this way. So what should we do? What we need to do right now is to multiply all the coefficients by 2. So now I'm going to put it down here. I'll take off those. So now we know the equation is balanced, but it's not written in the correct format because we have fractions. So yes, we have balanced equation, but it's wrong because of the fraction. So what I need to do here is to multiply everything, all the coefficients, multiply by 2. Multiply the coefficients by 2. So 2 times all the coefficients in the equation by the coefficients. Of course, coefficients are the numbers here. Of course, here will be 1. Here will be 1. Blank means 1. Okay. So multiply 1 by 2, the 1/2 by 2, and 1 by 2. Why do we multiply by 2? Because we need to get rid of the fraction. So you multiply by the denominator of that fraction. So multiply everything by 2. This will give you 2H2. 1/2 times 2 will give you 1 O2. Blank means 1. And 1 times 2 will give you 2H2O. Okay, and this is the same answer we got in the previous example. Okay, we just solve it in a different way, but you will get the same answer. Whether you use the first method, which is trial and error, you go back and forth, correct the fraction, the coefficient there, it will affect another coefficient. In the other side, you have to go back and correct it. Or this method that you focus only on the unbalanced element, but you could use fraction in the process. Okay, so this is a second method. Okay, so this is how you can balance the equation back and forth. So when you go to the games, in the introduction, it will show you the right answer when you get it. So you'll go through the introduction here. Then when you go to the games, it will not show you the process. You have to figure it out here. So here, if you click on the game, as you see, you have 3 levels. This is the game here on the bottom. You click on the game here. You see, this is the introduction here. This is the game. And the game has 2 levels, level 1 and level 2 and level 3. You are required to do level 1 and level 2. Level 3 is optional. Okay, level 3 is optional. You do the same thing here. You click on level 1, and it shows you here a certain reaction. You have to try to balance it. Again, always start maybe with 1 everywhere. Okay. Don't click check until you are ready. Okay. That's when you check whether you got it right or wrong. And again, you can see here you have 2 hydrogens. If I use here, you can count here. You have 1 times 2. So you have 2 hydrogen on the right-hand side. You have 2 chlorine on the right-hand side. But on the left-hand side, you have 1 hydrogen and 1 chlorine. Okay. 1 hydrogen and 1 chlorine. So maybe the easiest way is just to place 2 here, to change it to 2, change the coefficient to 2. So if you do that, you can see now you have 2 hydrogens and 2 chlorine, right? The hydrogen has changed to 2, and the chlorine has changed to 2 as well. So now it's 2 here, and here's 2. So the equation should be balanced. So you can now click check, and you can see it tells you that you got 2 points, it's balanced, and so on. So you can click next and go to the second one, and so on. Okay, you can see level number 1 will be easy, level 2 will be a little bit harder, then level number 3 will be the hardest. And keep track with your score, okay? Because that's what you're going to report in the lab assessment, and then will be more extra exercises that you have to do, okay? You have 5 challenges for each level, 5 challenges, so a total of 10 for level 1 and 2. All right, guys.